All right, number one, we have, let me go ahead and copy this graph down. We have a region, shaded region. We got D13, we got 9,4, which is C. We got B, which is 8,5. And we've got A, which is 210, 4, 6, 8, 10. So 210. So this is a bounded shaded region here, and we've got an objective function. Okay, and so we want to see the value of the objective function at different points. So the objective function is 3x plus 4y. Okay, so at point A, which is 210, so 2 is x, 10 is y. We'll just plug that in the objective function. So 3 times 2 plus 4 times 10. 3 times 2 is 6. 4 times 10 is 40. So 6 plus 40 is 46. So that's the value at point A. Okay. Now we got to do point B. So point B, we've got 8, 5. So I'm going to plug in 8 for x, 5 for y. So 3 times 8 plus 4 times 5. So 24 plus 20, 44. So the value of the objective function at point B is 44. Now we want to find the value of the objective function at point C. So point C is 9, 4. So I'm going to do 3 times 9 plus 4 times 4. 3 times 9 is 27. 27 plus 16, 43. So the value at point C is 43. Finally, point D is 1, 3. So I'm going to plug that in. So 3 times 1 plus 4 times 3. 3 times 1 is 3 plus 12, 15. So the value of the objective function at point D is 15. So now we're going to look at the maximum, which one had the highest value. Well, it looks like it'd be point A, 46. So 46 is my highest. That'd be the maximum value. And my minimum value would be the lowest, and that'd be 15. All right. Let's go to question 2. So now we're going to look at, we've got an objective function and we got some constraints. So we're going to graph the system inequalities using the constraints. I'm going to kind of graph them over here. I'm going to do my best because the points do matter. It's going to be easier when we graph it on there. So we got the objective function, z equals 5x plus 6y. We've got our constraints, which is constraints. And so we've got x is greater than or equal to 0, y is greater than or equal to 0, 2x plus y is less than or equal to 12, and x plus y is greater than or equal to 6. Okay, so we're going to graph these. Now I'm going to kind of give you a hint. When x is greater than 0 and y is greater than 0, that means we're going to be in this first quadrant. Okay, so I'm only going to draw one quadrant in here, and I need to do that, so I need to zoom in on the graph a little bit. Okay, so x is greater than 0. That goes like, it's just a vertical line here like this, and it goes that way. Y greater than 0 is a horizontal line, and that's going up. Okay, and I don't want to, basically this whole area is shaded by those two. So now let's look at this. And I'm going to do slope intercept on this. I'm going to change it up a little bit. I'm going to do, because I can get y by itself pretty easily. So y is less than or equal to negative 2x plus 12. So I'm going to go up to 12, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to go down 2 over 1, down 2 over 1. And so it might be, and I probably should do the intercept method here actually, because I want to see I want to see where it might be better if I did the intercept method here. I apologize. Because I want to see kind of, it's going to connect, I want to see where it touches each axis. So 2x plus y is less than or equal to 12. So I'm going to find the x-intercept, make y equal 0. Now, it doesn't matter how you do it on your, because it'll automatically trace on your graph when you do your graph. So x-intercept is equal to 6. And then the y-intercept, make x equal 0. So 2 times 0 plus y equals 12. Y-intercept's 12. So the y-intercept's 12. The x-intercept's 6. 5, 6. I want to try to be a little bit precise here. I'm going to connect these. And I'm just going to do a segment here because it's not going to go beyond these points. What's beyond this is not going to matter because it's already shaded in this region for the first two constraints. And so these down here and to the left are not going to be possible parts of the shaded region. Okay, so there's that part. Now, next, what I'm going to do is I'm going to figure out where it shades. So I'm going to pick 0, 0. So I pick 0, 0. So 2 times 0 plus 0 is less than 12. Is 0 less than equal to 12? That's true. So I shade towards 0, 0. It's just going to be going shaded down like that. Okay, I'm just going to lightly shade. So this whole area is bounded and shaded right now. But we have another constraint. So x plus y is greater than or equal to 6. On the x-intercept, make y equal 0. So x plus 0 equals 6. The x-intercept is 6. To find the y-intercept, make x equal 0. So 0 plus y equals 6. The y-intercept is equal to 6. So 3, 4, 5, 6. Okay, and so this would go right here. Okay, and they're all solid. Now, I'm going to look at the 0, 0. So pick 0, 0. Is 0 plus 0 greater than or equal to 6? Is 0 greater than or equal to 6? That's false. So the area that's going to be shaded is going to be this region right here, okay? So let's graph this first. So, and it would be easier if I would have done this all, I think, probably in one. So I'm going to do line, first off, x is equal to 0, y equal to 0. So you got to graph all the lines first. Then the next one had an x-intercept of 6 and a y-intercept of 12. And the next one had an x-intercept and a y-intercept of 6. So x-intercept is 6, y-intercept is 6. And now for the fill, we're going to fill in this region. Okay, so there's your bounded region. So now what you're going to do, what we now need to do is we need to find the points on the edges here. So what are the points at the edges? And I believe we can go ahead and move on to the next part. That's the graph. The points at the edges, the objective function in each corner of the grafted region. So let's look at, there's 3 parts here. There's 3 points. Okay, we've got 6, 0, 0, 6, and 0, 12. So I'm going to use 3 points. I'm going to use 6, 0. So I'll start with 6, 0, okay? So I'm going to plug that in for the objective function. So z equals 5 times 6 plus 6 times 0. It'd be 30 plus 0 would be 30. Okay, now let's do 0, 6. So I'm going to do z equals 5 times 0 plus 6 times 6. That's 36. And then lastly, we're going to do 0, 12. So 0, 12, z equals 5 times 0 plus 6 times 12. So that's 72. So I'm guessing they want me to put commas on this. 30, 36, 30, comma 36, comma 72. I'm not sure that is what they want. Okay, let me write that down. Okay, now the next part asks, use the values of part B to determine the maximum value of the objective function. Okay, the maximum value of the objective function is, so the maximum value is 72, and that occurs at the last point, 0, 12. All right, so now we've got an objective function. I'm going to do this a little wider this time. Z equals, and I'm going to put my space there to label this. Z equals 3x plus y. And the constraints, I've got x is greater than or equal to 0, y is greater than or equal to 0, 4x plus 3y is less than or equal to 24, and x plus y is greater than or equal to 3. Okay, so once again, I'm going to draw an L-shaped graph here. So you can see this. Because the reason why is because x is greater than 0, y is greater than 0. It's going to be this region here. Okay, and so now I'm going to do 4x plus 3y is less than or equal to 24 on the x-intercept. Make y equal 0. So 4x plus 3 times 0 equals 24. 4x equals 24. The x-intercept is 6. Now to find the y-intercept, you make x equal 0. So 4 times 0 plus 3y equals 24. Divided by 3, the y-intercept is 8. So the x-intercept is 6, 3, 4, 5, 6. The y-intercept is 8, 3, 4, 5, 6, 7, 8. And then we can pick 0, 0. We pick 0, 0, and let's plug that in. So 4 times 0 plus 3 times 0, is that less than or equal to 24? Is 0 less than or equal to 24? That's true. So I'm going to shade towards 0, 0, and these are all equal to's. Okay, so I'll shade towards 0, 0. Let's do the other one here. X plus y is greater than or equal to 3. So to find the x-intercept, make y equal 0. So x plus 0 equals 3. The x-intercept is 3. I'll write that over here. The x-intercept is 3. 0 plus y equals 3. The y-intercept is 3. So the x-intercept is 3. The y-intercept is 3. So that's going to be this region. And so then this one's going to be 0 plus 0 greater than or equal to 3. And that is 0 greater than or equal to 3. That's false. So I'm going to be shading away from 0, 0. So it's going to be this region again. Okay, so now we have 4 boundary points. Okay, so let's graph this real quick. So I'm going to click on the graph, do a line. X is equal to 0. Y is equal to 0. My next graph had an x-intercept of 6 and a y-intercept of 8. And then my next graph had an x-intercept of 3 and a y-intercept of 3. And then where do I shade? I fill in this region here. Okay. Now find the value of objective function at each coordinate. So for this, I'm going to plug in so I'm going to go back to this. Oops, I don't need to do that. Z equals 3x plus y. So my points here on my boundaries, I've got 3, 0, 6, 0, 0, 3, and 0, 8. So 3, 0 would be Z equals 3 times 3 plus 0, which is 9. Let's look at 6, 0. So Z equals 3 times 6 plus 0, which is 18. Let's look at 808 or 03, which is z equals 3 times 0 plus 3, which is 3. Then we've got 08, which is z equals 3 times 0 plus 8, which is 8. So those are my values. So find the value of the, so I'm going to use commas to separate this. It'd be 3, comma 9, or 3, comma 8. I don't know if the order matters. Comma 9, comma 18. All right, use the values in part B to determine the maximum of each one. So the maximums are highest, so the maximum is 18. So I'm going to put this in here. So the maximum is 18, and that occurs at 60. Right. All right, question 4. There's one of many vlogs going on in this classroom right now. So television manufacturer makes QLEDs and OLED televisions. The profit per unit is, I'll take some notes here. All right, X is number of QLED TVs, Y is number of OLED TVs. So the objective function would be Z equals, and I'm going to make an expression out of this. It'd be 125X plus 200Y. So that's going to be my objective function.
Is your camera any better on your MacBook? You can't see on there? No. I can still vlog, I just need to control see my face.
All right. The manufacturer is bound by the following constraints. Write an inequality of each constraint. So it allows for making at most. So we can do at most 450 QLED TVs. So this is X, so QLEDs, and at most would be less than or equal to. So that would be X is less than or equal to 450. So X less than or equal to 450. They could make at most 200, at most 200 OLED TVs. Oops. So at most 200 would be X is less than or equal to 200. Whoops.
I swear this mascara may be a little expensive, but it was never like. Wait,
Whoops. Oh, Y. Sorry, it would be Y, because Y is the variable for that. I apologize. It would be Y. Okay. All right, the cost for manufacture per unit is 600. So the cost is 600 for a QLED TV and 900 for OLED. And then you have to cannot exceed 360,000. So what does that mean? That means that 600X plus 900Y is less than or equal to 360,000. So $600X plus 900Y is less than or equal to 360,000. Okay. Now we're going to graph it, and I'm going to graph this over here. Okay. So I'm going to get some spot there to label this, but let's do, and when we graph it, we're going to do just the top quadrant here because it's going to be, we have to make at least 0 TB, so we're cutting off the rest of it. And so a couple of things we know is that we know that 450 to 200, I'm going to go by hundreds, 500, 600, 700, 800, 900. I'm actually going to first figure out the intercepts for this one right here. So I'm going to figure out the intercepts. So the x-intercept, make y equals 0. So 600x is equal to 360,000. Divide by 600, divide by 600. The x-intercept is 360,000 divided by 600. So 600. So the x-intercept 600. So 100, 200, 300, 400, 500, 600. To find the y-intercept, you make x equals 0. So 600, so that'd be 900. Y equals 360,000. Divide by 900, divide by 900. 360,000 divided by 900 is 400. So 100, 200, 300, 400. And so it's going to be a solid because they're equal to. So now I'm going to connect the dots. And I'm going to plug in 0, 0. So I'm going to plug in 0, 0 to figure out where to shade. So as I plug in 0, 0, 600x, 600 times 0 plus 900 times 0, is that less than or equal to 360,000? So 0 less than or equal to 360,000. That's true. So I'm going to be shading below here. Now my other constraints are x is less than or equal to 450. So I'm going to go to 450. I'm going to do a vertical line. Okay. And then I've also got y is less than or equal to 200. So I'm going to have a horizontal line here. Okay. And so, and I've also got all these boundaries too. So the shade, it's shaded below here, below here and to the left of this, but it's also bounded between here. So my region is this area right here. And so this is going to be my region. Now I will graph this real quick and we'll talk about this. So let's go graph that. So I've got an x, so the first, let's go that first one I did first. An x-intercept of 600, a y-intercept of 400. Okay. And the next one, 450. So I'm going to go vertical line at 450. Next one's going to be a horizontal line at 200. And the shaded region will be right here. Now within this area, let's go with that. Exit that out. Did that save? Oh, that didn't save. My fault. Actually, let me click on here. Sorry about that. So line 600, 400, and then 450, and then 200, and then shaded in this area. Now what we need to do is we need to find the boundary points. So let's look at the boundary points. So my first boundary point is 0, 0. So 0, 0 is a boundary point. Another boundary point is right here. This is 0, 200. Another boundary point's right here. That's 300, 200. So 300, 200. Another boundary point is here. This is 450, 100. And my last boundary point is here. Is 450 and 0. So I'm going to list those out. So my boundary points. I'm going to write those down here. So I've got 0, 0, 0, 200. Put this over here.
Sorry, Albert.
You're good.
I messed around my hands.
300, 200. 450, 100, and then 450 and 0. So you're going to plug each of these into the objective function. Okay, the objective function is up there. So z equals 125 times 0 plus 200 times 0. That's 0. Okay, so there's one of my values. X1 z equals 125 times 0 plus 200 times 200. And that's going to equal, it's basically 200 times 200, which is 40,000. Next one, 125 times 300 plus 200 times 200. So 125 times 300 plus 200 times 200, 77,500. And so the next one, 125 times 450 plus 200 times 100. So 125 times 450 and then 200 times 100. So 76,250. And then my last one is, I'm going to write this down here. Actually, I'm going to write it up here, actually. 450 and 0. So I've got 125 times 450 plus 200 times 0. And so 125 times 450 plus 200 times 0, that gets you 56,250. So they're going to ask me for my boundary points, and the boundary points are 0, 40,000, 56,250, 76,250, and 77,500. Okay. All right, now let's go to part E. Complete the missing portions below. So make the greatest profit by manufacturing. So the greatest profit came from the 77,500. So that was when X was 300. I'll show you real quick. The greatest profit came here. So that's when X was 300 and Y was 200. So we need to do 300 QLEDs and 200 OLEDs. And they made 77,500. All right. Let's go to question 5. So 5, we have a student earns $14 per hour for tutoring. So $14 per hour for tutoring. So per hour tutoring. And $7 per hour as a teacher's aide. So $7 per hour as a teacher's aide. We want to let X be the number of hours spent tutoring, Y number of hours spent as teacher's aide, write an objective function. So my objective function will be Z equals 14X plus 7Y, because you get $14 per hour tutoring and $7 per hour doing a teacher's aide. Okay. It's bound by the 3 constraints. We're going to do the 3 constraints. To have enough time for studies, they can work no more than 21 hours per week. So no more than 21 hours a week. What that means is that the total hours spent tutoring, X and Y, they cannot add up to more than 21. So X plus Y has to be less than or equal to 21. So the total number of hours per week for tutoring and teacher's aide has to be less than or equal to 21. Okay. So X plus Y y less than or equal to 21. Next, the tutoring center requires each tutor to spend at least 2 hours per week. So at least 2 hours must spend at least 2 hours tutoring per week. What that means is your x has to be greater than or equal to 2. So that means your x has to be greater than or equal to 2. Okay, because you have to do at least 2 hours a week. All right, the tutoring center requires each tutor spend no more than 7 hours per week tutoring. So no more than 7 hours per week tutoring. No more than 7 hours per week tutoring. That means that x has got to be less than or equal to 7. So x is less than or equal to 7. Because yeah. All right. Now we're going to graph it. And so I'll show you real quickly on here. All right. So on this, no more than 21 hours per week, I'm going to find the x-intercept. Do the intercept method. So to find the x-intercept, make y equal 0. So x plus 0 is equal to 21. The x-intercept is 21. Okay, I'm going to do about 3s, 6, 9, 12, 15, 18, 21. So the x-intercept's 21. Define the y-intercept. Make x equal 0. So 0 plus y equals 21. The y-intercept is equal to 21. 3, 6, 9, 12, 15, 18, 21. So the y-intercept is 21. So there's one of them. I'll go connect these dots. All right. Now, where is it going to be shaded? I picked 0, 0. Okay. Okay, welcome.
I got the restroom.
Yeah. So 0 plus 0 is less than or equal to 21. Is 0 less than or equal to 21? Yes. So you would shade towards there. Okay. Now for x is greater than or equal to 2, so I'll go to 2, do a vertical line, and I would be going this way. So this is x is greater than or equal to 2. X is less than or equal to 7, so I go to 7. So x is less than or equal to 7's here. And then basically this it's going to be shaded in between these two. So we're going to have this shaded region in this area right there. Okay. So let's go ahead and plot that on the graph. So 21. Oops. 21. 21. 2. 2. 7. 7. And where do I shade? I shade in the middle here, this area. Check answer. Okay. So now let's go ahead and establish what our boundary points are. So I've got 2, 0. I've got 7, 0. I've got 2, 19. And I've got this one here, which is 7, 14. Okay, so I've got those boundary points. Oh, they gave you those. That was nice. That was nice of them to give those. So we're going to write those boundary points down. So boundary points. So you got 2, 0, 7, 0, 2, 19, 7, 14. Okay. And so the equation is z equals 14x plus 7y. So 14 times 2 is 28 plus 0, so it'll be 28. Z equals 14 times 7. 7 times 0, so 14 times 7. 98. All right. Z equals 14 times 2. plus 7 times 19. So 14 times 2 plus 7 times 19. 161. Z equals 14 times 7 plus 7 times 14. 14 times 7 plus 7 times 14. 196. So these are your boundary points. So it'd be 28, 98, 161, and 196. 98, 161. All right. So the maximum occurs right here. Okay, the maximum occurs right here. So a student can earn a maximum amount of 7 hours per week, tutoring for 7 hours a week, and working as a teacher's aide for 14 hours per week, and they would make $196. So tutoring for 7, 14, and they make $196.